Welcome to Tech Talk IT, powered by Software Mind.
Hi, my name is Damian Mazurek, and I am Chief Innovation Officer at Software Mind. Today, I will talk about AI and especially large language model and how to use them in our application and how to build our product based on large language model. Let's start from the definition of the large language model. Large language models are machine learning models that were trained on the text data to generate human-like text, speech, using the natural language processing. And because their very specific architecture based on the transformers models, mainly because there are some models like Palm models from Google, which are the pathways models, but the rest is strictly based on the transformers architecture, where the researcher, which were, by the way, from the Google, discovered that if you put additional layer called attention layer to every model, then you will be able to better understand and better generate human-like content, human speech content. And to do this, you need to construct a large model that will be able to calculate three specific things from the attention layer called query, called value and the key. So in case of the model, there are the separate matrix, but you can imagine it like three additional information for every text that goes inside the model, where query is the question for the data, key is some key concept of this specific sentence, of the specific data, and the value is the information that is transferred through this specific sentence. And in, let's call it model, they are all matrix, but you can imagine it as this three different information that are put it in the context of the specific word, specific sentence that is the input for our model. In the process training, large language model is finding the best value for all of this free information for a specific sentence to create the output sequence of the specific tokens, words, that will describe or will be the best possibility, the best option, the best text, the best sentence, the best answer. So the best output for a specific problem. Under the hood, it's all about calculating the probability for the next word, let's call it next token, based on the input text sequence. So, for example, every model is calculating which word will be next in this sequence and what is the probability that this specific word will be there. And this is the first phase of training of such a large language model. So in the first phase, we just train the model to predict next word, next tokens. I will describe what is the difference between the word and the token. But at this moment, let's imagine that this is the same. So the model is learning based on the large amount of the data from a public internet or a specific data sets that were created only for this purpose to predict next word based on the input sequence of the words. When our large language model will be trained in this specific ability to predict next token, then we go to the second phase of the training. Now, let's imagine that this is like with a child. So at the beginning, we need to learn how to speak specific words, how to name specific things. And then when we master this ability, we are going to the more complex problem. So using these words, using these predicted values of the token, in case of the large language model, we train it and this training is called fine-tuning. So we're not training it from the scratch, but we're taking this part of the large language model that was trained on the large text data and now train it for a specific instruction. So here we put a specific instruction, like, for example, answer for me to this question, or create this kind of the lyrics, or, for example, create me a poem, or something like this. So we put a specific instruction where we know what should be the output for the model for this instruction, and we fine-tune this model on instruction level to make it more intelligent. And then, after these two steps, we have really well-balanced large language model with the high level of the intelligence that we can use in our systems and our products. To do this process, we need a lot of compute power. Normally, the cost of the compute power is measured in millions of dollars, $100 million per one training process. So starting from the scratch to the fine-tuning on the instruction. And because of this, most companies are using existing large language models and are developing another techniques that will provide them to use this model in the context of the specific data without fine-tuning or without training such models. And now we will explore how to use the model, how to create the app that will provide the extra data, for example, domain-specific data or our company data, how to use large language model, and how to achieve specific goals using this technology. First of all, let's explain tokens. So tokens are the representation of the specific, let's call it, piece of the text or of the content that represent the basic information unit. And it may vary based on the language that we are using to, for example, generate responses in large language model or the complexity of the sentence. But, for example, in English, most of the words are translated to the specific token. For example, the sentence hello world with the exclamation mark will be represented as 3 tokens. First one will be word hello, the second one will be word world, and the third one will be exclamation mark. And based on this representation, the token are used as the input and the output from our large language model. Next, very important thing at the beginning is that every machine learning model is always operating on the numbers. So the input for every model are numbers, and same as the outputs. In the case of large language model, there's the same principle. So our tokens need to be transferred or translate to the numeric form. And one of the techniques that allows to do this is called embedding. Embedding provides us the ability to represent every single token, every single word in n-dimensional feature space, where every word is described as a set of different features and it's called power of this specific feature. So, for example, if we have a word king, we can represent it like a man, like a power, like a landlord, and many other different things. So we represent this word as the vector of all of the specific features, which are represented as numbers. So, for example, 0 means that this specific feature do not exist in this word. And, for example, 1 means that there is the high importance of the specific feature that's describing that is describing the specific word. And thanks to this, we can represent very similar words inside this space of the features with the very close position between those two words. And thanks to this, we have, let's call it this, we have the way to capture the semantic context of a specific word. And this is important because when we will use our large language model and we will try to add some external data to it, we can use this specific technique to find the most relevant data that will be the input for our model. When we are building our system based on the large language models, or just we are using the large language models, then we need to provide some text that will be the input to the model. This text is called prompt. And there is a lot of techniques that allow us to create such a prompt, such a text. And the whole, let's call it, area of how to prepare the specific prompts is called prompt engineering. And in the large language model, there are two different, let's call it, methods to create specific prompts. First one is called zero-shot prompting, where you are just putting the specific sentence. So, for example, you can put the sentence, "Who is the current president of United States?" And the model will answer to it. Based on this one question and the general knowledge that this model already have based on the training process. But, for example, we can create more advanced reasoning processes, modifying only the prompt. And this is the next technique called few-shot or n-shot prompting, where we are providing different examples of the operation that we want to do. So, for example, we are creating the prompts that already answers to very similar questions. So we put the question and we put the answer and the method how we go to this answer from the question. And then we put, for example, 3 or 5 examples of this. And at the end, we ask our question. And then our model, based on the samples that are inside our prompts of previous operation that are very similar, and the reasoning process is very similar, can create the best answer, the best output for our question. And this is called few-shot prompting. And why this is important? Because when we are using these two techniques, we can create the more advanced way of communicating and using large language models. Every large language model is stateless. And that means that it do not have the memory of our recent conversation, of our previous prompts, and the outputs that were generated by it. Because of this, we need to address this element on the implementation level of our application and use large language model like only this creative part of our system, but all memory part we need to implement outside the model. So in this example, every time we send the whole conversation in the form of the JSON, where we have different roles. So, for example, for GPT-4, we have 3 different roles. One are the system messages, where we set the context for a specific model. Second one is the user messages, where we put our prompt. And the third one is the agent messages, which is the output of the large language model. And in every request to the model, using, for example, the REST API, we need to send the whole history of our conversation in this specific format. And based on this, our model create responses. And the problem is that the whole message, whole context of this history is counting as the input token number, because every large language model has some limitation on how many token it can take as an input and how many token it can produce as an output. And there is a couple of techniques how to manage the memory. First, and the most popular, is called conversational buffer memory, when we just put every single prompt that was created by us and was created by the model and just add another and another and another, having the whole conversation inside this buffer that is always sent to the large language model. This is a very popular technique, but the problem is that it consumes a lot of the tokens. And in the case of many different large language models, when we are using them as the hosted models, for example, on OpenAI backend or on the cloud, we pay per token that are sent to the model and per token that are generated by the model. So here we can very fast use all our token capacity for the input, and also it could be costly when we will send it every single time, hold the context. So those are the main disadvantage of this approach. But we can store the whole conversation inside one buffer and always put it into the input. The second technique that allows us to manage the longer conversation is called conversational summary memory. Here we create always the summary of our conversation, and we are not putting the whole conversation inside our input, but only the summary of the conversation that will allow the model to create a specific context. The main challenge here is to create a good summary that will always, transfer the whole information or the best possible information for our conversation, so our model will be the most accurate. But for the largest conversation, the summary method can lose some informations from the whole, let's call it, conversation perspective. The next one, which is very popular, is conversation buffer window memory. Here we are using the window for a specific part of our conversation. So, for example, we can put here last 5 prompts and the responses from the model, last 10, and based only on this limited scope, generate the specific output from large language model. And this is a very popular, let's call it, technique that allow us to fluently speak and with our large language model, but we will lose the specific context from the beginning of our conversation. The last one, and this is the new approach to create a specific memory for our large language model. It's called conversational knowledge graph base. And here we are creating a specific graph of our conversation. And based on this graph, we are using only the part of our conversation as the input to our model, but we can dynamically move through the graph and collect the information that we want to put inside our input context. Okay, so why I am speaking about this whole memory techniques? Because when we are building the application based on the large language model, we need to address all of these things. And this memory, we can call it the short-term memory, is the memory for our conversation. But also we have another type of the memory that will allow us to access the data that are not inside our conversation, but, for example, they are the data from our internal databases, they are the data from a specific research papers base, or any additional data source. To use this data, we need to create another memory cell, I call it long-term memory cell, which is mostly based on the vector representation of this data. And to do this, we use vector databases. So vector databases are storing the chunk of the data that are embedded into the vector space. And then when the specific question query for the model is created by the end user, then the first thing that is done is the search process of our vector database for any relevant data that are most similar to the question from the semantic perspective, and then take out this data from the database and put it as the input to the large language model with the question or the query from the user. Based on this data, and here we put the data that were retrieved from our vector database, answer to this question. And here we put the specific question for our user, and we send it to the large language model as an input. And then large language model, based on his reasoning skill that were created on these first stages of the training, is able to answer to our question or solve the problem based on the data that we put with the question in our input. And this is the technique that we are always gonna to use when we want to add external sources of the data without training the model on it. So then we just doing this a few shot step when we are providing, for example, the different data with the different answers, or a zero shot when we just provide the question and the data based on which we want to create the answer, and ask the model to answer this question based on this specific data. And those are the main steps for building our system. So first of all, we need to create a short-term memory for our conversation and the long-term memory based on the vector databases that will allow our model to access the external data sources. But the next challenge is that we need to somehow orchestrate it and create from all of the steps that we were talking about one single process that will allow our user to ask the model specific question or give him a specific task. To do this, there are a couple of the frameworks that allows us to chain specific steps of preparing this data, of preparing the prompts, and transfer them to the large language model. And one of the most famous framework, it's called the LangChain. And LangChain is the open source framework that was created for the large language model, where we can create a specific chain of steps, of events, that will prepare a specific prompts based on the data from the vector databases, will create a specific prompt template, so the user only asks a question, but the question is pasted inside a specific templates that allow to make a bigger and a better context for the model. And then it executes the model and retrieves the data to external user that start the question or start the process. LangChain by itself has the built-in integration with many different data sources, with many different large language models. So for example, it has built-in integration with the OpenAI backend. It has built-in integration with the open source models, large language models, using the Hugging Face APIs. And thanks to this mechanism, we can develop really quickly the chain that will create the prompt and execute it using a specific large language model. And this is a very cool framework that if you are interested in building the application that are using large language model, you should invest and you should learn. All in all, if you are thinking about building the system that is based on the large language model, you need to address the short-term memory, long-term memory, and the prompt preparation. Using frameworks like LangChain, Llama Index, you can do it really easy. So this is the main element of our large language model-based application. Thank you for listening to this episode and see you on the next one.
Learn from our experts how to feel it, live it, be it. And make sure to follow us on social media at Life at Software Mind.